Gable, our VP of Business Development, and David Brossard, our VP of Customer Relations.
Thanks, Lauren.
Thanks very much for joining everyone for the latest installment of an Axiomatics webinar, where today we are covering this topic of authorization that scales to the cloud and beyond. So David and I are regular presenters of webinars for you, and today's the latest show in our series of webinars. So David, it's good to be with you here again.
Yes, indeed. Thanks, Gerry. It's good to have you as well.
All right, so let's go on to the topic today. As usual, I'll set the scene and give a little bit of context to our conversation, and then David will take us into a more technical discussion and actually be doing some demonstrations as well. So our topic today deals with authorization for cloud-based applications and data systems. What we've seen happening over the years is that software is king these days. We looked up this quote from Mark Andreessen. It was actually from 2011. It's hard to imagine it was from that long ago, but we were seeing this effect now in full force, that almost every company, almost every organization is in some way, shape, or form a software company. And these days, that means it's cloud-based, it's API and microservice driven, but we also have to balance that with the compliance regimes of regulations, laws, and so on as a backdrop to our projects these days. And David, on the next slide, some of the additional technology trends that we see in some combination or another. So today we're talking about APIs and cloud, of course. APIs and microservice architectures are the preferred way to develop new business applications these days, where we have many, typically we have many small teams working independently using a DevOps, or what we like to say a DevSecOps model, where you can incorporate your security, at least some of your security infrastructure, into those agile deployment models. And like I said, it's often based on deploying these new apps in the cloud, but we see lots of hybrid scenarios where there are some applications that will still be on-premise in some form or another, other workloads migrating to the cloud, but we're even seeing some cases where cloud-based systems are coming back on-premise. Where organizations found it not suitable to run there. On the data side of things, we see both relational database migration to cloud services like Azure SQL, Amazon RDS, and so on, different forms of managed Hadoop services, but also different kinds of data warehouses or data lake technologies being deployed in the cloud. And we need to secure that data in order to properly use it and effectively use that information. And then another theme for our talk today is about scalability. And that also has lots of different dimensions because as we build out microservice and API-based applications, there are now potentially hundreds or thousands of these components or objects to manage. Of course, the number of devices continues to astronomically increase, along with data records. You know, the IoT devices and sensors and these mobile devices creating massive amounts of data, different kinds of user and team alignments, and of course, again, the backdrop of regulations and other compliance requirements. So David, moving forward to the next slide. Our job or our goal here at Axiomatics is to help you protect this valuable, sensitive, and regulated information, but also allow you to properly share it, use it, expose it to customers, partners, regulators, and do it in a way that's uniformly secure and standards-based. So that's the goal here of Axiomatics, is to help you with this process. And at Axiomatics, we're also all about dynamic authorization. And what does that mean? Well, do you have access to a resource or not? Within Axiomatics, software products, we are defining the policies and rules and attributes for gaining access to these valuable resources, and then enforcing those rules at runtime. And if you click one more, David, thanks. This is applicable to many different types of application and data resources. Today we'll talk mostly about APIs and microservices, but it also is applicable to data sources that are either on-premise or cloud-based.
Yeah, and Gerry, I often like to say that it's dynamic because we ask for authorization at the time of access, not before. It's not a birthright, if you will. It's something that when you attempt an action, that's when we check whether you're allowed to do what it is you're trying to do, which lets us use contextual information like risk or time of day or location of the individuals involved.
Yeah, that's a good distinction in that, in fact, we are runtime authorization, not administrative time authorization. Okay, click again, David. Awesome. Yeah, and another thing we want to address today is the fact that authorization logic is often hard-coded or tightly coupled into the application itself. Certainly, this is a legacy consideration of many of the applications that have been built in the past. And we want to make sure that going forward, when we're building these microservice architected applications, that we use cleaner architectural considerations and decouple that access control logic from your application code to give you more flexibility in deploying, keep the auditors and the security folks happy, and also make it much more efficient for your developers to focus on the logic of the business applications they're building. So on the next slide here, David, we talk a little bit about the model that we use. For dynamic authorization at Axiomatics, it's commonly referred to as ABAC, attribute-based access control. But as David just said, the real secret here to the benefits of ABAC are a couple of things. One is the different attributes that can be used in defining the rules and enforcing the access at runtime. And it's the policies that tie this all together and allow you to incorporate the context of not only who the user is, but many other variables, things like what device they're using, whether there's a time of day constraint or a location consideration, what's the relationship of the user to the data. All of these characteristics or factors or attributes can be taken into consideration because the policies are the logic that represents whether that particular user should have access to that API, that business function, or that data record at runtime.
And Gerry, just to stress what you just said, the policies are really the secret sauce here because they tie together all these different attributes, as you said. And the policy language is rich enough and flexible enough to cater to any number of scenarios that you might have within your enterprise. We see things that go from regulations within the financial sector all the way down to export control, to manufacturing, to getting access to pharmaceutical data. So the breadth of what the policies can express is really rich.
Excellent. And David, this concept of ABAC is, or attribute-based access control, is not something new, and we're not the only ones that talk about it. On the next slide, we have a quote from some of the researchers at NIST, the National Institute of Standards and Technology. They do a lot of research on this topic, as well, of course, of other security topics. And this is a quote from a recent book that the team published, that ABAC is the latest development in an evolution of access control models that go back more than 40 years. Probably even before you were born, David, but maybe not so much for me.
Definitely. Oh no, you were well into your 40s by then.
Yeah, something like that. But anyway, it's it's the latest iteration of access control models, so we do think it gives you the most flexibility and efficiency in building modern day applications.
And I think, Gerry, just to stress again, the whole part on attributes, it's going beyond the identity dimension. If we look at the quote, it says the latest development and evolution of access control. Historically, access control models, be it access control lists or role-based access control, they've focused on the one dimension, the user and their identity, and maybe a couple of groups here and there, but still very egocentric. With ABAC, you get a chance to expand, as you said on the previous slide, to other dimensions, the resource, the context, time, environment, all these different parameters that we can use to make the right decision.
Absolutely right. And then David, I think the next slide is the last one for me. So when we talk to different organizations about the dynamic authorization, it's not all about the technology, although we definitely will dig down a little deeper into those technical details today. There's always a business driver associated for making any kind of IT or technology investment. So we want to make sure that we're in alignment with these different concerns and requirements. And today, as we see in the bottom with the red circle, today we're focusing on the developer community and the capabilities and the benefits for this audience, in particular about making it more efficient for you so that you can focus on the business logic of the application that you're building, whether it's a new customer portal, a new set of API functions, to enable you to utilize an infrastructure service that can be deployed in very flexible ways right alongside your applications, and offload that burden from you so that now you can have policy-based controls to the sensitive function or those sensitive data objects, and have a central way to do reporting, audit control, certification of access, and so on. So David, I think it's time for me to hand over to you to talk more from a technical perspective, how we can deal with these requirements.
Thanks, Gerry. All right, so moving on, I'm going to dive a little deeper into what I call the developer's view of authorization, and looking at what it means to actually apply authorization to your applications and how you would do that. So first of all, much like authentication, logging, data storage have been externalized from an application, authorization should as well. And that's why I call it authorization as a reusable building block, meaning that you should stop writing authorization code into your applications, and instead you should focus on what your app is supposed to do and just do that and do it well. And of course, it means that you're going to be saving time in developing your app, and then you're going to be delegating any authorization decision making to an external reusable building block. And that, of course, that building block is going to be your policy decision point, if you want to use terminology found in the ABAC report. So that's the first aspect, authorization as a reusable building block, so that you developers can save time and can have a consistent way of applying authorization across your multiple applications. And we're going to see, Gerry, how these different principles, they all tie together with the whole microservices paradigm that we're seeing more and more of. The second requirement that you want to have for your authorization is that you want authorization that scales. Oftentimes, when I talk to customers and I tell them about what we do about ABAC, they're like, oh, but is that going to work? Is that going to scale? Is the performance going to be good enough? And I like to reply that when you use authorization as a building block on the side of your app, you're making performance visible. And when I say you're making performance or the lack of performance visible, because there is a cost to doing security, of course, be it authentication, be it authorization. But when you actually tightly couple it with your app, you can't measure it. And more importantly, you can't make it better. But with authorization as an external building block sitting alongside your app or sitting centralized within the enterprise, you want an authorization service, an authorization functionality or function that can actually scale up and down. And that's actually what we've built here at Axiomatics. We have an authorization service that can scale up on demand when you need to tackle more authorization needs. And actually, Gerry, you and I this morning, we were talking to a partner, and you were referring to some of the customers we have in terms of their scale. And we have customers that handle authorization for 200 million plus users. We have others that tackle it for thousands of applications within their enterprise, others that tackle it for millions and millions of transactions per day. So we've seen it scale in many different directions. The bottom line is you want to design your system in a way that you can scale up. But it's not just scaling up. It's also about being elastic. And I have to give credit to one of my colleagues who's worked a lot on making authorization elastic and integrating with Kubernetes. What we mean with elastic authorization is, of course, the ability to cater to larger environments, like I said in the scaling slide, but also just the ability to scale down when you don't need as much capacity. So you want to have an authorization building block, an authorization service that can be orchestrated, that can be where more of it can be spun up when you need to have more capability, more load, and it can be torn down when you don't need that much capacity. So you want to have elastic authorization. And what's worth remembering is that this is possible because both in the case of scaling up or in the case of scaling up, scaling down for elastic authorization, the way the service is designed, and we'll see that more in detail in a few slides, is that authorization is stateless. So whether you ask for a decision, you ask an authorization question to one authorization service or to another, it won't change the decision you'll get back because the authorization services are stateless, which is why it's so easy to scale up, which is why it's so easy to have elastic deployments. There's no magic tricks that we're doing behind the scenes. And that brings us, Gerry, to this slide here, which is essentially an acknowledgement of the world we're evolving in, that little by little everything is becoming a focused application, a microservice, if you will, an API, if you will, and each and every bit that developers are writing, each and every application that developers are writing, or just one piece of functionality, one hexagon, if you will. So on my slide here, you have your products hexagon that focuses on products only. There's another one that focuses on ticketing, another one that focuses on, say, payroll, so on and so forth. Well, much in the way that you have these different pieces that you can assemble together, you're going to have your policy decision that you're going to be able to plug into the different pieces that need decision-making, that need authorization. So your policy decision-making is just another hexagon right there in the middle, and you can plug it in whichever way you like. That's going to be made even, sorry, go ahead, Gerry.
Yeah, sorry, David, before you move off the slide, I just wanted to point out, the other two hexagons here we have for OAuth and Open Identity Connect. We talked in previous webinars about how an ABAC system integrates very nicely with those OAuth and token-based environments. So just another tangent, and that we've got a recording of that webinar available as well.
Indeed. And so I've been alluding to it through the few slides that I just showed so far, but essentially we see authorization as a microservice, as a functionality that you can run and install anywhere you like, on-prem, in the cloud. Of course, it's the focus of today's webinar, and we'll see later as a sidecar as well. But what does it mean, essentially, authorization as a microservice? Well, first of all, like I said, it's stateless and immutable. It doesn't matter how many times you ask the question, if you don't change the authorization services configuration, you will always get back the same answer. With, of course, the slight caveat that if you use time in your decision-making process, if you ask them an authorization request at 3 p.m., you might not get the same answer as if you ask for the question at 3 a.m. But apart from that, if you send an authorization service, an authorization request, and you don't change the configuration, you will always get the same response back. That's important because it will let us scale up and scale down, load balance your authorization service, and that's how you can actually achieve scale. The second part is that it has a very well-defined interface. Historically, authorization frameworks, if we look at what we've had in the past, either based on access control lists or based on ABAC or based on homegrown systems, authorization services always had different ways of querying for authorization. It could be the way we do it, which is a binary question. Can I do this? It could have been, oh, give me the roles of the user. Or it could have been, give me the permissions of the user. So many different ways of querying for authorization. In ABAC, we move away from that. We define a well-defined process of how you query for authorization. It's a yes/no question. You get a yes or a no back. It's called permit and deny. We'll see that in the demo. And you can get additional information with it, such as a reason for denial, but the interface is extremely well-defined. And Gerry, going further, we also, within the XACML technical committee, of which we're members, we also decided to define a technical interface, not just an abstract interface, but also a technical interface and a lightweight one, so that as many developers can connect to the authorization service, and so that they won't have to waste too much time, if you will, in the plumbing, but rather focus on what they want to do, which is their app and their authorization. And to do that, we designed and implemented a REST JSON interface so that you can actually post a JSON message and get a JSON response back that'll contain the decision. And I'll show you what that looks like in the demo. It's extremely lightweight. I remember doing a webinar with you, I think, Gerry, or with Jonas, about REST and JSON, and we compared the size of a traditional authorization request with the size of a JSON authorization request, and I think it was 80% smaller, if I remember correctly. So it's all about efficiency and ease of integration. It also means that you can integrate with more languages than ever before, not just the traditional enterprise languages like Java and .NET, but also Python, Ruby, Lambda functions in AWS. I had an interesting email exchange with a customer this morning that was telling me they use Lambda combined together with Axiomatics to do authorization for S3. So having a well-defined interface based on lightweight standards is making those scenarios possible. Also, it's a bounded context. The authorization service only focuses on one single thing and one thing only, and that's delivering authorization, period. It does not do anything else. It does not do authentication. It doesn't do federation. It doesn't do token validation. It just focuses on authorization, which makes it so easy to use, if you will, and so easy to scale up and scale down. And the last part is that it's fault tolerant. Especially in the new iterations of the products at Axiomatics, we have a cloud-native PDP, and that's what I'm going to be using in the demo. We've designed it in a fault-tolerant way. If it fails, you kill it, and you start a new one. As simple as that. And starting up a new authorization service is a matter of seconds, if not less. Which means that now you can have cloud orchestrators like Kubernetes do the management of your authorization services for you, and you don't have to worry about maintaining a heavyweight enterprise web application server inside of which you'd have your authorization web application. Forget all that. Now it's all moving to standards way of running applications, container-based such as Docker, and then orchestrated using the likes of Kubernetes. And I alluded to different ways of deploying your authorization application. Historically, Gerry, you know that a lot of our customers, if we go back a few years, they would tend to have an enterprise team that would buy the product and then install it as an infrastructure authorization service that would then cater to the entire enterprise. That's been the traditional model. I think it's very much linked to the SOA way of thinking. But as we're going down the microservices and lightweight API path, we're realizing that we don't necessarily want to have this single point of failure in a way, no matter how well you could, scale it. You actually want to be able to give the authorization engine to the different application teams and let them run the engine themselves. And then in that case, the engine is a sidecar to your application. So you've still decoupled the authorization from the app or from the microservice, but you don't necessarily run a centralized authorization service. Rather, you rely on that sidecar and the policies or the configuration you give the sidecar. And that brings us the fact that you can scale, the fact that you're elastic, the fact that we can have different deployment models, that we can run as a sidecar, the fact that we can be orchestrated natively, the fact that we're configuration-based rather than code-based, that leads us to being what we like to call cloud-native authorization, meaning that it doesn't matter where you want to run, we'll be there with you, running with you, including in the cloud, of course. And more specifically, being cloud native to us means a couple of different things. It means that when we designed the authorization engine, we made sure, our engineering team made sure that they followed the 12-factor app principle, which means that there's a couple of factors or principles that you have to follow when you're developing an application. And don't quiz me on all 12 because I don't remember them all and I don't have my cheat sheet with me. But they followed that, and it means that the authorization engine can run in cloud effortlessly. Rewind. We'll have to edit that in the recording. It also means that it can be containerized, such as Docker, and we've been running inside of Docker for a couple of years now. Like I said, it can be orchestrated, and I'll show you that. And in my demo, I use Kubernetes, and I also use a metric server that'll be measuring the CPU usage and will be telling me when I need to spin up a new pod. And of course, it means that we can run in any of the major cloud platforms, be it AWS or Google Cloud Platform, Azure, Pivotal, and many more. And we can either use Docker and Kubernetes in these environments, or even use those cloud-specific solutions, such as Beanstalk, to do very much the same. So here's a little diagram of what it would look like. You still have this notion of your policy enforcement point at the very top, your PEP that sits between a client or a user and a backend application. And now that PEP, that enforcement point, the form factor of which could be many different things. It could be a Lambda function, it could be an API gateway. That enforcement point will talk to a load balancer, and that load balancer will distribute the load across all the authorization services that it knows. So here we have the Access Decision Service or the Cloud Native PDP that's tackling the load. And you can see how the authorization services are being spun up and spun down through Kubernetes. And there's a configuration here in the bottom right corner that tells how to create the different authorization services. So in that particular example, I'm using 3 pods. In the demo I'll be running, we're only using 2 pods. So in one of your early slides, Gerry, you mentioned that we do ABAC, we do authorization, and that we could do it on any number of technologies. You mentioned big data, data lakes, applications, and APIs. APIs is one of the interesting and easy low-hanging fruits for attribute-based access control. Given that APIs and microservices have well-defined interfaces, it means we can easily write authorization policies for those APIs. And given that typically with APIs, you'll either have an API gateway in front of the API, or you'll have a framework that lets you have interceptors within the API stack. It means that we can easily do enforcement for those APIs. Enforcement on the way in, by the way, but also enforcement on the way out, which means that we can do extremely fine-grained transactional authorization, as well as data-centric authorization, where we might be filtering records we don't want to return, or potentially masking or redacting information we don't want to return. So here's an example of what an API integration would look like. You have your user on the left-hand side, could be their mobile device, their computer, whatever it might be. They're trying to reach out to an API endpoint on the right-hand side. That API endpoint could be anything you like. Could be a microservice, could be a more traditional SOA web service, could be a REST JSON API. And in the middle, you're going to have your API gateway doing the interception, creating the authorization request in step 2 from the original call in step 1, sending that off to the authorization service. So here it could be your traditional on-prem authorization service. It could be your cloud native authorization service. It really doesn't matter. That's more of a deployment question. And then based on its policies, the authorization service will reach a conclusion, and it will return that decision back to the API gateway in step number 5. So here in this case, we have a yes permit. And based on that, the API gateway will forward the call to the backend in step 6, and then the API response will come back in step 7. And then if we do authorization on the way back, we could do an additional check. If not, we can just return the decision back to the caller in step 8. And it's worth noting that we do integrate with a wide range of API gateways, all the way from the more traditional ones like DataPower, IBM DataPower, to the newer ones like MuleSoft, Kong, AWS API Gateway, Apigee, and so on. So being cloud native authorization also implies that we work in the same way and we're configured in the same way as applications being built for the cloud. It means that we're in line with DevOps, and more specifically, like you said, Gerry, DevSecOps. And it means that as a developer, I want to be able to write my app, and I want to be able to write my authorization from the same environment. I want to be able to test my authorization exactly the same way I test my application. I want to have the same life cycle. I don't want to have to waste time and depend on a central team that will be provisioning me with access to an authorization service. I want to control it all. Okay, I don't want to have these dependencies. And that's exactly what I'm going to be showing you in a demo. I put together a sample environment that shows how, as a developer, I can write an app, and then I can write my own authorization as well. And speaking of which, it's demo time. So in the demo, I'll be showing a couple of the technologies I use on a day-to-day basis. First of all, ALFA, the abbreviated language for authorization, which is a lightweight syntax for writing policies. We'll look at REST JSON and how we send authorization requests and we process authorization responses. We'll look. We'll be using Docker. We won't really be seeing Docker. It's behind the scenes, and we'll be using Kubernetes as well for an Elastic demo. So the first part of the demo, DevSecOps, we're going to be writing a policy in Alpha. We're going to use a command line utility to convert them into XACL, and then we'll spin up an instance of the cloud native PDP. It'll be running locally on my computer, and it'll be consuming the policies we just wrote. And then I'll use Postman and or plain old Java to send authorization requests to my cloud native PDP. So with that said, let's go ahead and jump in to my demo.
David, while you're setting that up, I'll just remind our audience to submit their questions in the GoToWebinar control panel. We've got a few questions in there already, including someone who wants to know what those 12 development app factors are. So we need to look that up before we're finished here.
Yeah. Well, you just open a new tab in Google 12-factor app and you'll see them.
All right.
I'm sure this was a trick question from you, Gerry.
Absolutely.
All right, so this is Eclipse. This is the IDE I use most of the time. And what we're looking at now is just some sample code to create an authorization request. We'll get back to that code in a minute. The first thing I'm going to start up with is the policy I'm writing. So let me close these different little windows. And here on the right-hand side, I'm going to open up my folder called source alpha, and I'm going to open up a file called main.alpha. This is my main policy. So you can see, Gerry, that this is a really simple file. It contains a main policy here, lines 3 through 10, and inside it contains a link to a policy called transactions. Now, I don't want to run that just yet. Okay, I just want to run a super simple policy to begin with. So I'm going to bring in an allow all policy. And if we click on the allow all policy, it's going to take us to the definition here below. And you'll notice that the policy allow all, well, guess what? Not a big surprise. It allows everyone access to everything. Okay? So if I run this policy now, if I package it up and give it to my cloud native PDP, I should get a permit no matter what my authorization request is. So let's do that together. On the right-hand side here in this little window, I'm using an Ant script file. Ant is one of those utilities developers use or have used to automate tasks like building code, compiling and packaging code, so on and so forth. I use it here to spin up and kill my cloud native PDP. So I'm going to start off by killing my cloud native PDP. I'm not sure it was running, so it might fail. Nope, okay, killed it, great. And I'm going to clean that up. And now that I've done that, I'm going to go ahead and generate my authorization domain from the policy we just created. So I'm going to fire that task up. And you can see, by the way, at the bottom of the screen, there's a little console window that shows the different tasks happening. So it deletes the old package. It converts the policies into the expected format, and then it generates a domain for me that contains the whole configuration my authorization service needs. So now that I've done that, I can go ahead and run my cloud native PDP. So it's going to fire up. And as soon as it's fired up, I can go ahead and go send an authorization request. So like I said, there's a couple of different ways I could do that. One of the ways would be to use a Java JSON PEP SDK. So that's the second project I have here in my Eclipse. I have a bit of code where I can go ahead and send an authorization request. And in that little client, what I'm doing is I'm connecting to an endpoint. So I'm running everything locally on my computer. So you can see I'm going to my computer's name and then port 8080. And then I'm sending in a XACTable JSON request. And then below that, more importantly, I'm building a request. Now, given that I have a permit all policy, it doesn't really matter who I am. So I could give myself any random role. And I could just say, oh, I want to delete, and I could say everything. So this is a really, really bad request. What I'm saying now is that my name is Alice. I have any random role. I want to delete. I want to delete everything. And by the way, the owner of that everything is Alice. I'm actually going to remove that line. Okay, so I'm not going to pass in the owner. On these key value pairs, these are the attributes that make up the policies, that make up the authorization requests. So Gerry, what do you think is going to happen if I send that off to my authorization service? What answer do we expect?
Well, we expect an allow or a permit, but I think what's also important here is you're at least testing the connectivity to that PDP service.
Absolutely. I'm doing two things. I'm testing that I can actually talk to it, number one. And number two, I should be getting, if all goes well, of course, the demo gods might not be with me today. I should be getting a permit back. So let's give it a go. I'm going to run my little program. And in the console below, I get a permit back. Simple. Okay. And you saw that
so far, so good.
So far, so good. It didn't take much time, by the way, between the time I sent it and this time I received it. So it's blazingly fast. I'm not measuring here, but that's something we could do as well. We're looking at, on standard hardware like my laptop, you're looking at sub-millisecond level response time. Now, of course, the policy that I put into play here is not that interesting. It doesn't do much. So I'm going to go ahead and put a more meaningful policy. So I'm going to bring in my transactions policy. I'm going to click on it, and we're going to look at it together. So this is where attributes come into play. My policy will only apply to transactions. Okay, so sending in everything the way we did it before in the request is going to make it fail. Secondly, it's only going to allow view. So only viewing on transaction is allowed. And then finally, we're going to look at the role the user has. So either the user is a manager, and in which case they can view any given transaction, or the user is a customer, in which case they can only view their own transaction, the transaction that they own. So it's very simple. All these little keywords, username, owner, role, actions, these are keywords you can define. So you can define them to be whatever you like in your own environment to reflect your own use cases. So I'm going to go ahead and generate a new set of policies. I'm going to kill my cloud native PDP first. There we go. I'm going to go ahead and generate my new authorization domain. So you can follow the progress in the console below. I'm cleaning up my environment, and then I'm generating my new policies. And from the policies, I'm generating my new authorization domain. There we go. And it's all from within my IDE. So the whole point of DevOps and DevSecOps is I don't have to jump through multiple hoops to get what I want to do. I can just do it from within my IDE through scripting. Okay?
Yeah, you don't have to rely on the central IT team, like I used to work in, to implement these policies for you.
Exactly. You have the control.
Mm-hmm.
And I'm going to run my cloud native PDP. Which, by the way, I'm kind of hiding things, but there's a YAML file that describes how you want to run your cloud native PDP. And if I open it up, you'll notice that it defines things like what ports you want to run on, your logging level, which right now is worn. It also contains the path to the domain file. So this is the domain file I'm generating all the time. It contains a bunch of other different configuration information, and there's more than just these options as well. So this is just a subset of what you can set. So now that my cloud native PDP is running, I can go back to my client, and if I run this, I shouldn't get a permit anymore. I might get a deny, I might get a not applicable. There we go, we get not applicable, meaning, hey, you sent me an authorization request. I have no idea what it means. Okay, send me a good authorization request. So let's do that together. Now I'm going to say, I'm a customer and I want to view a transaction. And I'm going to bring in ownership information. Okay, so Al, is the customer. I want to view a transaction that Alice owns. If I run that, I should get authorization permitted. So let's see. And we do. Great. If you look at the bottom of the screen, you can see that it says permit. Awesome. So that's kind of the first part of the demo, Gerry. I'm going to let it be at that for now. Just a couple more comments. You could actually run this in Postman. So Postman is one of those API testing tools, and in Postman right now, I have a little set of authorization requests called Cloud Native PDP, and you can see I built up different scenarios. So for instance, can Bob the contractor view transaction 123? And well, if we send that one, I'm going to get a no back because I don't have a use case for contractors. I only have use cases for customers and managers. So you can see the response getting back here. It's pretty much the same thing as what the Java JSON SDK was doing, except that you're using a third-party tool to do the same thing. If you try Carol, if she's trying to look at the body, by the way, Carol, she's trying to view something owned by Carol, so she should get access permitted. And she does. Look at the response below, access permitted. Great. Now, that was part one to the demo. If we go back to the slides, the second part is showing how you can scale up and scale down, essentially how you can have elastic authorization. And this is, I have to give credit to two colleagues at Axiomatics who've been working a lot on Kubernetes lately and who've helped me be ready for this webinar. So one is Joffrey, one of our developers, but the other person, of course, is Mark Berg, who allegedly is listening in. So I had to give him credit because otherwise he wouldn't be too happy. Joke aside, thanks. So what we're going to be doing here is I have a Docker environment running in my computer, and within that I have a Kubernetes environment. And if I check the usage of my nodes right now, you'll notice that right now I have an image called ADS. It's my Cloud Native Authorization Service. And right now the usage is 1%. The CPU usage is 1%. If it goes above 50, I'm going to start spinning up new instances. And at most, I'll be generating 2 pods, 2 instances, okay? I won't go beyond that. Right now, I'm only running 1, okay? You can see that I ran it earlier before this webinar just to verify everything was working fine. So I can actually get the list of pods. And you can see I have a single one now. And I have those, by the way, those commands in the slide here. So if anyone on the webinar wants to go back and find the commands, they're right here in the slide, so they're safely stored. So what I'm going to do is I'm going to go back to Postman, and I'm going to use my other project. And in the other project, I have a series of authorization requests that are more or less large, and I'm going to run them in batch mode. The whole point of doing it in batch mode is that I want to stress my authorization service, and I want to see it tackle the increase in load. So I'm going to run 1,000 requests, and we're not going to see the 1,000 finish, by the way. But we'll see the authorization service scale up, which is really nice. So I'm going to run that off. And you can look at the progress here. So it's 0% now. It's going to go 1%, 2%, so on and so forth. You can see on the right-hand side the numbers. So it's generated 20 so far, and it's going to keep generating them. And if I go back to my command line and I get my HPA, we're going to see that right now it claims that only 1% CPU is used. What's happening is the metric server is measuring CPU usage every 30 seconds. That's the polling period in my setup. So I have to wait for 30 seconds before I can ask again how much is being used. If we're lucky, we're going to see a number below 50 but greater than 1. And then eventually it's going to go over 50, and we're going to see, say, 67. And then we'll actually see a second PDP spin up. What's interesting, though, is that my Postman is going against the load balancer, none the wiser, and therefore the load balancer will take care of distributing the load across the different authorization pods we have in this setup. So here we're still on 1%. Let's give it a bit more time.
This is where we have to sing and dance or have a little interlude.
Yes.
To accommodate for the delay here.
Yeah. There we go. So here's the middle number. We got 37 going. So we're going to wait for another 30 seconds. So warm up your vocal cords, Gerry.
All right, will do. Well, it looks like the Mark has taught you well on how to use the Kubernetes because everything is working so far.
Yeah. And what's amazing, one of the things that amazed me, I'm relatively new to Kubernetes, but I've restarted my computer a bunch of times since I got ready for this webinar, and you can see that it's still running perfectly fine. You can see that it's been running for 5 days straight. In one of the different views, it actually said how many restarts it had gone through. So that's kind of interesting. So we run 29% of our requests here.
Yeah, we should be getting close now.
Yeah, 52. So this is really interesting because it reached the limit, but it hasn't spun up the new pod yet. It's probably a little too early, but now I can actually wait and see when the new pod is going to show up. Actually, I might be able to see that if I look at my pods view instead. No, still one. Let's give it another 30 seconds.
Historically, how would you need to deal with something like this, David? How would you need to be monitoring capacity before adding another instance?
So it would have been a more manual process. So you would have had a load balancer. That doesn't really change too much, but the deployment would have had to already contain all the authorization services you wanted to use. So the typical deployment we see with customers is that they have a load balancer, and behind it they have 2 authorization services, and that's one setup for one data center. And if we're talking a global 50, global 100 business, then they'd likely have a data center in Asia, one in Europe, one in the US. So it's very static. All authorization services that might be needed at some point would have been there to begin with, right? Ooh, my number went back down. I guess I didn't go high enough on this one.
I think I spoke too soon about how well your demo was going.
Well, no, I think it actually worked because what happened is it went back down because it spun up the new pod, quite simply.
Okay. Okay.
So it kind of proves it's just that I was talking too much, not that it ever happens to me. So yeah. Either that or my postman is frozen, which could be the case actually, it looks like. No, there we go. 62%. Yep.
All right. Well, our audience may need to take that on faith that it spun up the extra one and took care of the extra capacity.
I have my backup slides, of course. I always do that. So here we see that we ran the load using Postman. This is just one of the many tools you could use. You could use JMeter as well if you wanted to use that. It doesn't really matter. And then eventually what happens is you get 2 pods in that list. You see here in my little text, I have these 2 pods running. And then if you look at the middle one, you can see my usage is 145%. And then below, if you look at get deployments, you can see that I'm running 2 instead of running 1. So
right.
Yeah, I guess it's too good of a computer.
All right. Excellent.
And that wraps it up, Gerry.
All right, David. Excellent. Thanks so much for that. So yes, we do have some questions in the queue here, so please do add any additional questions that you might have. But David, in the meantime, there's lots of events happening in the near future. You and I will be at the European Identity Conference in Munich in May. So we both have sessions there. And then also at Identiverse coming up in June of this year in Washington, DC, where we also both have sessions for that conference. So we're definitely looking forward to that and hope to see some of you there. On the webinar scene, we've got a couple more in the queue that are not yet on our event page, but we'll be doing a follow-up webinar with a couple of partners, Savient for one of them and Radiant Logic for the other. So hopefully you'll register and tune in for those. Now, David, we've got a couple questions here. Now, you showed using Docker and Kubernetes in particular, but those are just examples of containers and orchestration tools that we can use, right?
Yeah, it's just an example. I suspect that you could do the same thing in other orchestrators and other container tools. As it turns out, Docker and Kubernetes happen to be some of the most popular ones we see out there, and that's why we started with these. But I'm sure that any other one would work just as well.
Yeah, and it's been a principle of the engineering team to develop the cloud-native PDP service as being agnostic to whatever cloud platform or set of tooling that we use. So that's definitely a benefit. So we're not tied to any particular platform or set of tools.
Correct. It's important that we don't want to be tied into any one particular vendor or model. So adhering to standards and adhering to vendor neutrality is very important to us.
Absolutely. And it seems like I sparked interest about OAuth and OpenIDC, David, when I mentioned that on the one slide.
Yep.
Maybe we could just say a few words about that. So, OAuth tokens or JSON Web Tokens, JWT tokens, are often used in API use cases and scenarios for authentication, certainly for delivering authentication information in these tokens, but they can also be leveraged for access control. And there's a couple of patterns that we've witnessed that are potentially problem areas where you don't have enough information in the token, so the downstream API gateway or the downstream microservice has to look up additional information, which could make the system chatty, or you end up overloading or bloating the token with too much data, and that becomes a heavyweight factor. And the other aspect is your APIs or microservices can be bloated with application logic if it needs to figure out what to do with this particular user token and this requested API call. So that can all be offloaded to the authorization service. And like I said, we dove into that much more in detail in another webinar recording, so we can share that with you. Did you want to say anything more about that right now, David?
No, I think you're spot on. Usually, when I talk about OAuth versus ABAC, it's a very legitimate question that we hear a lot of. OAuth to me is more delegation of access. So you're delegating your access to your service to another service. For instance, how you would let Facebook post on your Twitter account, as an example. The OIDC, of course, is the authentication layer and the standards on top of OAuth to be able to enable authentication and social login.
Excellent. There's also a quick question about a copy of the slide. So we do, as Lauren said earlier, we do make a recording of the presentation, and we'll post a link to that in the very near future. So you'll get a follow-up email with a copy of that link, so you can look up the details again or share it with colleagues that maybe could not attend. And David, one other thing you mentioned that there's a question about is, how quickly you can spin up an authorization service. I think you showed in some of your scripts how quickly that happens. And what other ways are there to script that or automate it other than the Ant utility that you mentioned?
Yeah, so actually the Ant utility is perhaps a little old-fashioned. I don't know that nowadays people would do that, but let me just show you what it does, because what matters is what's inside. So let me open up my Ant file, and then let's go have a look at my run cloud native PDP. All it does is run a jar here, okay? So this is my the Cloud Native Authorization service. The form factor is a single jar. You run it using java-jar. You pass it in a deployment file, which is what I have here, and then you're good to go. That's as simple as that. And you can run it from the command line. You can run it from within Eclipse with Ant, for instance, which is what I'm doing. You could also install it within a Docker file, which is what we did for the Kubernetes demo. You could use it directly in AWS Beanstalk as well if you wanted to do that. So there's many different ways. And spinning it up, spinning it down, like I said, is a matter of seconds.
Excellent, excellent. Well, David, it looks like we're at the top of the hour here, so we should wrap up today's session. Thanks so much for doing the demo. I think this is some great level of detail. Cloud native capability that is in such demand these days from our customers and prospective customers that we're talking to. Thanks to everyone for joining us today. And like I mentioned, we hope to see you at some of the industry events we'll be at in the near future or on the next Axiomatics webinar. Thanks so much for joining.
Thanks, everyone. Thanks, Gerry.